Hi students. Okay, today in this lecture we learning the topic is bilinear transformation. Okay na? So in the previous lecture we completed conformal mapping definitions and some problems on translation, magnification, rotation and inversion. Okay na? So now here bilinear transformation. Okay, first see the definition of bilinear transformation. So the mapping or transformation W is equal to f of z is equal to az plus b by cz plus d. So this is called bilinear transformation. Already we known that linear transformation. What is a linear transformation? This function, the transformation W is equal to f of z is equal to az plus b. Okay, now f of z is equal to az plus b, that is called linear transformation. So now we have bilinear transformation, that is the ratio of the two linear transformation, that is az plus b by other linear transformation is cz plus d. So that is equal to az plus b by cz plus d. This is called bilinear transformation where a comma b comma c comma d are complex numbers. Okay, now here coefficients here complex numbers such that the condition is AD minus BC is not equal to 0 is called bilinear transformation. So if AD minus BC is not equal to 0 and dw by dz, and dw by dz means differentiation. So this is a bilinear transformation here. Now differentiation with respect to z, dw by dz is not equal to 0, then the above transformation is conformal. Definition of conformal, compulsory its derivative is not equal to 0. So the bilinear transformation derivative is not equal to 0. So this transformation is conformal. Okay. So since w is equal to f of z is equal to az plus b by cz plus d, that implies take the inverse. W is the function of z here. So now you finding z is equal function of w, that is f inverse of w. So z is equal to f inverse of w and f right inside, that is z is equal to f inverse of w. So w is equal to a function of z and z is the function of w, so interchanging. So right outside, now simplification of finding z value in terms of w. So that is equal, you are getting minus dw plus b by cw minus a. This transformation is called inverse bilinear transformation. So w is equal to function of z mo bilinear transformation, and z is equal to function of w and f inverse of w, that is called inverse bilinear transformation. Okay. So one of the points here, every point in z plane is mapped into every point in w plane except at z is equal to minus d by c. At every point in the bilinear transformation, every point, one point to mapped into the in the domain, there is a codomain, the range here. So every point is mapped into in opposite plane, that is w plane, except z is equal to minus d by c. So in case z is equal minus d by c, that is not defined, the value is not defined. Okay na? So next, every point in w plane, take the inverse and inverse part. Every point in w plane is mapped into every point in z plane, that is the inverse mapping. So inverse law at except w is equal to a by c. In case w is equal to a by c, the value is invalid, that is not defined. So okay na? So this is bilinear transformation, and similarly its reverse, that is inverse bilinear transformation. So this is the definition. Okay. See the next one. Yeah. Next definition, fixed points or invariance points of bilinear transformation. Since W is equal f of z is equal to az plus b by cz plus d is a bilinear transformation if z maps into itself. అంటే z నుంచి zకి మ్యాపింగ్ అండి. మనకి ఏంటి, మనకు z నుంచి w కదా మ్యాపింగ్, bilinear transformation. బట్ హియర్ ద మ్యాపింగ్ ఈజ్ z to z, అంటే w ఈజ్ ఈక్వల్ టు z. సో దట్ ఈజ్ ఈక్వల్ టు w ప్లేస్లో z రీప్లేస్ చేయండి. సో z ఈజ్ ఈక్వల్ టు az plus b by cz plus d. Now this is solving. So this is one of the equation. What is the equation form? A quadratic equation in z. మనకి z లో సెకండ్ డిగ్రీ ఈక్వేషన్ ఎగ్జిస్ట్ అవుతుందండి. దిస్ ఇస్ అ క్వాడ్రాటిక్ ఈక్వేషన్ ఇన్ z. సో దెన్ ద రూట్స్ ఆఫ్ ది అబోవ్ ఈక్వేషన్ 1 ఆర్ కాల్డ్ ఫిక్స్డ్ పాయింట్స్ ఆర్ ఇన్వేరియన్స్ పాయింట్స్ ఆఫ్ బైలీనియర్ ట్రాన్స్ఫర్మేషన్. ఓకేనా, మనకి ఇచ్చిన బైలీనియర్ ట్రాన్స్ఫర్మేషన్లో మ్యాపింగ్ z to z, అంటే w ప్లేస్లో z రీప్లేస్ చేయాలి. వి గెటింగ్ ద ఫ్రమ్ ది బైలీనియర్ ట్రాన్స్ఫర్మేషన్ వి గెటింగ్ ఏ ఈక్వేషన్ దట్ ఈస్ అ క్వాడ్రాటిక్ ఈక్వేషన్ ఇన్ z. Now finding the roots of that equation is called the roots are called fixed points or invariance points of bilinear transformation. Okay, so if the roots are equal, in case after finding the roots of the bilinear transformation, then the bilinear transformation is parabola. Okay, now when finding the fixed points are equal, then the bilinear transformation is represent a parabola. Okay na, so this is the definition of bilinear transformation. Okay, next one. So next definition, cross ratio. This is a very important. If there are 4 points z1 comma z2 comma z3 comma z4 taken in order, then the ratio, చూడండి the ratio లో చూడండి difference between any two points. ఇక్కడ చూడండి z1 minus z2 into z3 minus z4 by z2 minus z3 into z4 minus z1. This is the ratio. This ratio is called cross ratio for any 4 points. The difference between the points and after finding the difference product and ratio, that is called cross ratio. Okay, so note, a bilinear transformation is preserved the cross ratio for 4 points. So bilinear transformation is exist అవుతుందండి for 4 points in cross ratio. So for example here, if z1 comma z2 comma z3 comma z4 are points in z plane and the points w1 comma w2 comma w3 comma w4 in w plane, then the cross ratio is exist kada bilinear transformation, that is equal in w plane is equal to in z plane, w plane equal to z plane, that is equal to w1 minus w2 into w3 minus w4 by w2 minus w3 into w4 minus w1. So equal to the in z plane the cross ratio. This is the cross ratio in the w plane. This is the cross ratio in z plane. So that is equal. So that is z1 minus z2 into z3 minus z4 by z2 minus z3 into z4 minus z1. So this is using the cross ratio. We have to finding the bilinear transformation for given any 3 points. Okay, w is the in terms of z, that is w is equal to f of z, you have to finding az plus b by cz plus d. So when given any 3 points are given. Okay na, this is important, the long question will given on this topic. Yeah, to find bilinear transformation in given 3 points. So when the given 3 points in w plane is mapped to in w plane, so then how to finding the bilinear transformation for given 3 points, see that. So we can find the bilinear transformation, w is equal to Az plus b by cz plus d with help of cross ratio. So already finding in the previous slide, in given 3 points z1 z2 z3 and in z plane, w1 w2 w3 in w plane, then so this is a cross ratio exists. You can choosing only 3 points together. One point is w, one point is z in z plane, w plane. So and one point choosing w together. And so by using the cross ratio, one of the formula, this formula using for finding bilinear transformation. చూడండి మనకు అక్కడ w4 ప్లేస్లో w తీసుకుంటున్నాం, z4 ప్లేస్లో z, ఓకేనా. w minus w1 into w2 minus w3 by w minus w3 into w2 minus w1. Similarly in z4 ప్లేస్లో z minus z1 into z2 minus z3 by z minus z3 into z2 minus z1. So using this formula to finding bilinear transformation, okay na. Yeah, see the problems. First problem, first example, find the bilinear transformation which maps that points z is equal 0 minus 1 I in z plane onto w is equal to I 0 infinite in w plane. Also find the image of the unit circle mod z is equal to 1 under mapping bilinear transformation, ఓకేనా. సో ఇక్కడ చూడండి మనకి జెడ్ ప్లేన్లో ఏమి ఇచ్చాను, మనకి డొమైన్, ఇన్ ద డొమైన్లో మనకి ఇచ్చిన పాయింట్ 0 minus 1 I అంటే z1 z2 z3 విచ్ మ్యాపింగ్ ఇన్ w ప్లేన్, కోడొమైన్ w ప్లేన్లో ఏమి ఇచ్చాను మనకి, దిస్ ఇస్ w1 w2 w3, ఓకేనా. సో ఫస్ట్ ఫైండింగ్ bilinear transformation, that is a which form was a bilinear transformation, w is equal to az plus b by cz plus d, that is a finding. So that is the given points in the z plane and in w plane by using the cross ratio. So this is the using cross ratio, substituting all points, okay now, that is equal to here. So one more thing here, w3 is equal to infinite కదా చూడండి, మనకి directly substituting w3 is equal to infinite is not defined, అవునా. So now cancel the w3. So w3 is take out the common in LHS, okay na, that is w3 is equal to infinite, we have to take out the common w3 from numerator. So and denominator of the left side in the above equation we have equation. So ఇక్కడ w3 common, so ఇక్కడ w3 common, so from numerator denominator w3 comes, that is a cancel, అవునా. So remaining here w minus w1, w3 common కదా అంటే w2 by w3 minus 1. So denominator like w3 common, w by w3 minus 1 into w2 minus w1, that is equal, in the right side is the same, no change, okay na. So now substituting z1 z2 z3 and w1 w2 w3, okay, that is equal to, so putting the given values in the above equation we have, so w minus w1 is equal to I, అవునా. So this is in denominator w3 కదా infinite and 0 minus this value by 0, this is w by w3 అంటే w by infinite and 0 minus 1 into 0 minus I, this is a w2 minus w1 కదా. So next similarly substituting z minus z1 z2 minus z1 by substituting all z1 z2 z3 in this one in the right side, okay na. Now simplification is that is equal to here, so here minus, okay, denominator లో మైనస్, ఇది క్యాన్సిల్ అయిపోతుంది చూడండి, దిస్ మైనస్ మైనస్ క్యాన్సిల్ అంటే w minus I by minus I, that is equal to here minus z into minus zi by, so here minus common is say I minus z, okay na. So that is equal to here minus I right outside, so minus right outside the cross product, w minus I is equal to Zi minus z by I minus z. So W is equal to minus right outside I plus Zi minus z by I minus z. Now take the LCM. So take the LCM, I minus z in the right side, I into I square into minus 1, I minus zi plus zi minus z. Now here minus, this is a cancel, minus of 1 plus z by I minus z. So therefore the bilinear transformation W is equal to, ikkada minus common in the denominator, minus cancel, chudandi z plus 1 by z minus I. Which form here? W is equal to AZ, AZ plus B by CZ plus D. ఇదే కదా మనకు కావాల్సిన బైలినియర్ ట్రాన్స్ఫర్మేషన్. చూడండి అదే ఫామ్లో వచ్చింది చూడండి. W is equal to AZ, A is equal to 1 plus B is equal to 1 by CZ అంటే C is equal to 1 plus D is equal to minus I. So this is the required bilinear transformation. Okay. So next finding, using this one, how to finding the image of given figure. Okay. So now to find the image of in W plane of the given unit circle, mod z is equal to 1 in z plane. Under mapping bilinear transformation, W is equal to z plus 1 by z minus I. So now using inverse bilinear transformation. So from this one bilinear transformation here, now finding inverse and z is equal to in terms of W. So they take the cross product, W into z minus I is equal to z plus 1. So Wz minus Wi is equal to z plus 1. So that is equal to here, Wz minus z is right inside, Wi right outside, W plus 1. So therefore z is equal to Wi plus 1 by W minus 1. This is the inverse bilinear transformation. Z is equal in terms of W. So this is the bilinear transformation. Okay na? So given figure is mod z is equal to 1. So given unit circle mod z is equal to 1, but z is equal to here Wi plus 1 by W minus 1 is equal to 1. W is in the codomining in the range here. So that is equal to substituting. So mod Wi plus 1 is equal to mod W minus 1. So W is equal to the image. So image of the Z kada. Z emo x plus iy. W is equal to u plus iv kada. In the domain lo complex number u plus iv. So substituting W is equal to u plus iv into I plus 1. That is equal to mod u plus iv minus 1. Now simplification is, so that is equal to mod of ui minus v plus 1 is equal to mod of u plus iv minus 1. So that is equal to, take the real part here. What is the real part here? 1 minus v plus imaginary part iu. Okay na? Ikkada real part u minus 1 is the real part plus I into v. So this is also complex number again. X plus iy. So mod of x plus y is equal to square root of kada. Mod of x plus iy is equal to square root of x square plus y square kada. Ikkada em vastundi square root of 1 minus v whole square plus u square is equal to ikkada square root of u minus 1 whole square plus v square. Now square root kada. So now squaring means square root on both sides. Now squaring on both sides. Square root is a cancel. 1 minus v whole square plus u square is equal to u minus 1 whole square plus v square. So that is equal to expand 1 plus v square minus 2v plus u square plus 1 minus 2u plus v square. Simplification is 2v is equal to u. That is equal to u is equal to v. The straight line which is the required image in W. So what is the given figure? Mod z is equal to 1 the figure in z plane kada. So daniki manaki image find out చేసిన under mapping bilinear transformation we getting the image is a straight line. So circle ki straight line exist అయిందండి. ఓకేనా? So this is the required problem for using bilinear transformation. Okay. So see the figure. So మనకి ఇచ్చినది in z plane the figure circle mod z is equal 1 అవునా. So now under mapping the bilinear transformation w is equal to z plus 1 by z by si. సో మనకి ఏమొచ్చింది ఇమేజ్ స్ట్రేట్ లైన్ u is equal v కదా, ఇక్కడ u axis v axis is the image the passing through origin. So this is the required image of the given figure mod z is equal to 1. Okay. Yes, next example. Find the bilinear transformation that maps the points z1 is equal minus 1, z2 is equal 0, z3 is equal 1 onto w1 is equal to minus 1, w2 is equal to minus I, w3 is equal to 1. So given points in the z plane and which is mapping onto w plane the given points. Now finding bilinear transformation. Okay. So given z points and w points by using cross ratio. This is by using the formula. Yeah, substituting all values in this formula, that is equal to w1 is equal minus 1, w plus 1, w2 is equal to minus I minus w3 is equal 1 by w minus w3 is equal to 1, w2 minus w1 minus I plus 1. Similarly, substituting the right side z1, z2, z3. Now simplification is, so w plus 1 into minus common. So minus common in the minus common numerator and denominator. I plus 1 by w minus 1 into I minus 1. That is equal to here. Ikkada minus also cancel on both sides. Ikkada minus common. Ikkada minus common. On both sides minus is a cancel. So z plus 1 by z 1 minus z. Okay. So denominator kuda minus cancel ayipinchudandi on both sides. Okay. So that is equal to here. So now your rationalization in the left side, w plus 1 by w minus 1 into I plus 1 by I minus 1 andi. Ikkada denominator lo I minus 1 undi. Now rationalization here dividing and multiply with I plus 1 by I plus 1. Okay na. Now simplification is, so after simplification is w plus 1 by w minus 1 into minus 1 plus 1 plus 2i by minus 1 minus 1, that is equal to z plus 1 by 1 minus z. So that is equal to w plus 1 by w minus 1 into 2i by minus 2 is equal z plus 1 by 1 minus z. So that is equal to here. Now cross product here, w plus 1 into 1 minus z into I, 2 cancel, w minus 1 into z plus 1. So now product on both sides, w into here, multiplication, w into z minus 1 I plus zi minus 1 into I minus I. So ikkada w into z plus 1 minus z minus 1. Okay na. So that is equal to w into z plus 1 right inside. Okay na. So zi minus I right outside. So w into z minus 1 into I minus w of z plus 1 is equal to right outside minus zi plus I. Already ikkada minus z minus 1 already in the right side. Okay na. W common the same as z into I minus 1 minus so again ikkada z common chudandi, z common the same as ikkada I minus 1 remaining here minus of I plus 1 into w, that is equal to here z common minus I minus 1 plus I minus 1. So therefore w is equal to here right outside the denominator minus I minus 1 into z I minus 1 by I minus 1 into Z minus I plus 1. చూడండి, దిస్ ఈజ్ ద రిక్వైర్డ్ బైలీనియర్ ట్రాన్స్ఫర్మేషన్. చూడండి, W ఈజ్ ఈక్వల్ ఎలా ఉంది, ఇది AZ అవునా, AZ ప్లస్ B బై CZ ప్లస్ D అవునా. సో దిస్ ఈజ్ ద రిక్వైర్డ్ bilinear transformation. This is the A, this is the B, this is C, the D. Okay, so bilinear transformation is one of the problem, is a long question, very very important question andi. Okay na. So next example, find fixed points of bilinear transformation. W is equal to 3z minus 4 by z minus 1. This is a given bilinear transformation. Now finding fixed points. So what are the fixed points? The mapping from z to z. W place lo z replace cheyali manam. Okay na, we getting a quadratic equation. Now finding the roots of that equation got called fixed points. So given bilinear transformation, so put W is equal to z. Z is equal to here 3z minus 4 by z minus 1. So right outside is the cross product. So z square minus z is equal to 3z minus 4. So this is the quadratic equation in z. Z square minus 4z plus 4 is equal to z. So z minus 2 into z minus 2 is equal to 0. So z is equal to 2 comma 2. So the roots are 2 comma 2 equal andi. Okay na. So 2 comma 2 is the fixed points, and also the bilinear transformation represent is parabola, because equal equal fixed points already I told in the note. So fixed points are 2 comma 2, that is given transformation is represent a parabola. Okay na, this is the fixed points. Yeah, next example, find two bilinear transformation whose fixed points are 1 comma 2. ఇక రివర్స్ అండి, మనకి ఇందాక గివెన్ bilinear transformation to finding fixed points, but here given fixed points, now finding bilinear transformations. Okay na. So assumption, this is a bilinear transformation. W is equal to AZ plus B by CZ plus D. Okay na. So for fixed points assumption, W is equal to Z again, substituting W is equal to Z. So now here finding the cross product, CZ square plus DZ, right inside AZ plus B, right inside minus AZ plus minus B is equal to 0. So that is equal to dividing by C, Z common in the middle term. So z square plus d minus a by c into z minus b by c. This is the quadratic equation andi. Now finding the roots of this equation are fixed points, but already given the fixed points is 1 and 2 kada. So already we have to finding the a quadratic equation in fixed points 1 comma 2 assumption. Okay na. So by given fixed points are 1 comma 2, so by known equation from the roots 1 and 2, that is the formula is z minus 1 into z minus 2 is equal to 0. This is one of the quadratic equation whose fixed points are 1 and 2. That is equal to z square minus 3z plus 2 is equal to 0. So this is the, from the given fixed points is the quadratic equation. But already finding the quadratic equation from the bilinear transformation, observing 2 and 3 are both are equal. అంతే కదా, మనకు కావాల్సింది we have to finding bilinear transformation కదా. ఆల్రెడీ మనకు వచ్చిన క్వాడ్రిక్ ఈక్వేషన్కి ఆల్రెడీ ఫైండింగ్ క్వాడ్రిక్ ఈక్వేషన్కి రెండు కూడా సేమ్ అవుతాయి అవునా. సో దట్ ఈస్ ఈక్వల్ టు బై యూజింగ్ కంపేరింగ్ ఈక్వేషన్ 2 and 3 బోత్ ఆర్ ఈక్వల్. సో దట్ ఈస్ ఈక్వల్ కోఎఫిషియెంట్స్ ఈక్వేట్ చేయండి. d minus a by c is equal to minus 3 minus b by c is equal to 2. ఎందుకంటే మనకు ఇక్కడ ఫైండ్ అవుట్ చేసిన క్వాడ్రిక్ ఈక్వేషన్ మనకి ఇచ్చిన ఫిక్స్డ్ పాయింట్స్కి వచ్చిన ఈక్వేషన్ బోత్ ఆర్ ఈక్వల్ అవుతాయి. మనం ఫైండ్ అవుట్ చేసింది అదే కదా. సో దట్ ఈస్ ఈక్వల్ టు d minus a c is equal to minus 3 minus b by c is equal to 2. So d minus a is equal to minus 3, b is equal to minus 2c. So that is equal, d is equal to a minus 3c, b is equal to minus 2c. ఇక్కడ అబ్జర్వ్ చేయండి, ఇక్కడ db అనేది డిపెండెంట్ వేరియబుల్ అవునా, ac is a ఇండిపెండెంట్ వేరియబుల్ అండి. మనకి ఏ వాల్యూ సి వాల్యూ సబ్స్టిట్యూట్ చేసుకుంటే మనకి డిబి వాల్యూస్ ఎగ్జిస్ట్ అవుతాయి, అవునా. సో డిబి ఈజ్ ద డిపెండెంట్, ఏసీ ఈజ్ ద independent. Okay, now substituting here. So from the equation 1, bilinear transformation is W is equal to, అక్కడ మనం B ప్లేస్లో D ప్లేస్లో రీప్లేస్ చేయాలి. సో AZ minus 2C by CZ plus A minus C. చూడండి, this is a required bilinear transformation, AZ plus B plus CZ plus D. సో ఇదేమో A, B, C, D. Okay, now so we have to finding two bilinear transformation, and any two substituting A value, C value, substituting here we getting the any two bilinear transformation. So ఇక్కడ A is equal to 1, C is equal minus 1. మీ ఇష్టం అండి, you can do any two values, but don't will come repeat the same రావద్దు by using the A value, C value, choosing any value. Okay na. So substituting A is equal to 1, C is equal to minus 1, therefore W is equal to Z plus 2 by minus Z plus C. Okay, now this is one of the bilinear transformation. Next, choosing A is equal to C is equal to 1. So that is equal, we getting W is equal to Z minus 2 by Z minus 1. This is the any two bilinear transformation. Now substituting any other values, we getting the another one. So 2 is enough. Okay, na? So this is a bilinear transformation when given fixed points 1 and 2. Yeah, so this is bilinear transformation definitions and cross ratio and problems on bilinear transformation. This is a very important one, long question guarantee. Okay na. For more videos, please do subscribe my channel, like and share it. Thank you.